In our study of geometry, and we are going into triangle proofs at this particular point, continuing with them. We'll talk some more about CPCTC. That's the corresponding parts of congruent triangles are congruent. In case you're wondering what what is on the board, maybe you think it's some sort of a snuffleupagus impaled on a hook. It is not. It is a fly that we use to catch. This particular one will catch trout, smallmouth bass, saltwater fish, and so on and so forth. You'll notice that there's a little tiny microbarb there, so it comes out of the fish's mouth real easy, and it's relatively, compared to other things, pain-free. All right, as we do for the week, we're going to have 2 lessons and then a quiz on the second day of the week, which will be the next lesson. We'll do some review questions, we'll do prepping for proofs, and we'll do some more work with triangles congruent and CPCTC. As usual, let's do some stop and start. Go ahead. Okay, so opposite angles of a parallelogram are going to be congruent to each other, so that's 155, and consecutive or supplementary. So don't manage, I'm sorry, I didn't change the scratch work over there, but 25 is this angle here, and 25 is directly across. Okay? And remember that it all relates back to parallel lines cut by a transversal, how consecutive interior angles add up to 180. And then if we put another set on the opposite side, we would also have to go with the 25 and the 155. Okay, find the value of x. Go ahead. Don't worry about changing to 7x minus 11. Don't do that. Just go by what the diagram says. 5x minus 11. Okay, so the opposite sides are congruent. So 5x minus 11 is 3x plus 5. Subtracting 3x from both sides, 2x minus 11 is 5. Adding 11, 2x is 16. Dividing by 2, and x is 8. So they now want to find the value of AD, so I have to substitute that 8 back in for the x. So 4 times 8 is 32, minus 5 is 27. Next up, go ahead. Remember, those 2 angles form a right angle. Okay, since they form a right angle, they are complementary, which means they're going to add up to 90 degrees. So 6x plus 14 plus 4x plus 6 is 90. Combining like terms, 6x's and 4x is 10x's, 14 and 6 is 20. Subtract 20 from both sides, 10x is 70. Divide by 10, and I get, ding, 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 x is equal to 7. It only wanted me to find x, so I am done. Oh, what are they asking for, as Mr. Braze would say? All right. I know the one angle is 75. Find all the other angles in this diagram. Go ahead. Okay, so in this diagram, we know all the acute angles are equal to each other. We know all the obtuse angles are equal to each other. And we know one acute and one obtuse add up to 180. So therefore, the missing obtuse angle has to be 105. In fact, all obtuse angles, because they're all equal to each other, have to be 105. And of course, all the acute angles are equal to each other, so those guys are all 75. Okay, good. Next up. So what we have here is the measure of an exterior angle. Here it is on the outside, 9x minus 14, equals the sum of the 2 remote interior angles. So the 2x plus 6 plus the 5x have to add up to 9x minus 14. Same side, same operation. Let's combine those like terms. 5x's and 2x's are 7x's, plus 6 is 9x minus 14. Always start by subtracting the smaller number of x's. So 6 is equal to 2x minus 14. Adding 14, 2x is 20. Dividing, and I get x is 10. The problem only says find x. I'm done. Oh, what are they asking for? Go ahead. Okay, so I have 121, and these 2 angles up here add up to 180. So the missing angle has to be 59. And because this is an isosceles triangle, the other base angle is also 59. Well, if I add up 59 and 59, I get 118, which means the vertex angle has to be 62. But these guys are vertical, So that's also 62. But these guys are isosceles, so angle D is also 62. And 62 times 2 is 124. 124 taken away from 180 leaves me with 56 degrees for the missing vertex angle. Find X. Okay, pretty straightforward here. Again, the measure of the exterior angle, where this 130 is equal to the sum of the two remote interiors. So I don't know why I forgot to change the 55s. The bottom line is it's 50 degrees, and here's the answer down here. Okay, 50 degrees it is. Now, the next question is, what is the shortest angle and so on? We're not going to do that one. Last but not least is this proof being done. What's the reason for the last step? Go ahead. Okay, so you have the given statement that PS is congruent to RQ, and you mark those off with or they mark them off for you. Then you are going to get the fact that T is the midpoint twice. So RT will be congruent to PT, and ST will be congruent to TQ. So they will be congruent by either SSS, or if you had gone the vertical angles route, you could have found SAS. So SSS will do there. The so far summary. The measure of an exterior angle of a triangle equals the sum of the two remote interior angles. We covered that. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. Consecutive angles of a parallelogram are supplementary. Those three were all covered in the first slide. All the obtuse angles are equal in the parallel lines diagram. All the acute angles are equal, and one acute and one obtuse add up to 180, and the three angles of a triangle also add up to 180. Plus, we did an example with side, side, side.